Okay, so now I'm going to go ahead and I'm going to do my slope fields. So when I do xy, dy, dx, I'm plugging in my coordinate points. So 0, 0, that's going to give me a 0, 0, 2, and that's going to give me a 0. So I get these. And then I plug in 0, 1, and that's going to give me a negative 1. And then I go 0, 2, and that's going to give me a negative 4. And then 2, 1 is going to give me a 1. And then 2, 2 is going to give me a 4. Okay, so that gives me my slope field. To write the equation of the tangent line, I want dy dx at the coordinate point 2, 3. So I get 3 squared over 2 minus 1, which is 9. So y minus 3 is equal to 9 times x minus 2. That's the equation of my tangent line. To find f of 2.1, that's approximately 9 times 2.1 minus 2 plus 3, because I moved the 3 to the other side. So f of 2.1 is approximately equal to 3.9. I want to find the particular solution, so I separate my variables first. So 1 over y squared dy is equal to 1 over x minus 1 dx. I take the integral of both sides. So remember that this is y to the negative second power dy. So I have, take the antiderivative, negative y to the negative first power is equal to ln absolute value of x minus 1 plus c. So negative 1 over y is equal to the ln absolute value of x minus 1 plus c. Plug in my initial condition, so negative 1/3 is equal to the ln of 2 minus 1 plus c. So c is equal to negative 1/3. Plug this back into the original equation, so negative 1 over y is equal to the ln absolute value of x minus 1 minus 1/3. So negative 1, multiply both sides by y, ln absolute value of x minus 1 minus 1/3. So then y is equal to negative 1 over the ln absolute value of x minus 1 minus 1/3. Okay, so now then we do the next one. And I got to sketch a slope field again. So I would do my grid x, y, dy, dx. And then if I do negative 1, 0, that's going to give me 0. 0, 0 will give me 0. 1, 0 will give me 0. And 2, 0 will also give me 0. So all of these are 0. And then I have negative 1, 1, which will give me a positive 1/2. So that goes like this. And then negative 1, 2 would give me 2. So more like that. Continue my chart over here. So then 0, 1 is going to give me 0. 0, 2 will also give me 0. And then 1, 1 is going to give me negative 1/2. So negative that way. 1, 2 will give me a negative 2. So something like that. 2, 1 is going to give me negative 1. And then 2, 2 will give me negative 4. Write the equation of the tangent line. So I have dy dx, and I want this at negative 1, 2. So I have negative of negative 1 times 2 squared over 2, which gives me 2. So y minus 2 is equal to 2x plus 1. Particular solution, so 1 over y squared dy. I'm going to separate the variables, negative 1/2 x dx. Take the antiderivative. It is just like the other one we did, so negative y to the negative first power is equal to negative 1/2 times 1/2 x squared plus c. So negative 1 over y is equal to negative 1/4 x squared plus c. Plug in my initial condition, so I get negative 1/2 is equal to negative 1/4, negative 1 squared plus c. So c is equal to negative 1/4. So negative 1 over y is equal to negative 1/4 x squared minus 1/4. So negative 1 over y is equal to, I can find a common denominator, so negative x squared minus 1 over 4. So cross multiply, negative 4 is equal to y times negative x squared minus 1. I can factor out a negative 1 in here, multiply everybody by negative 1, so 4 is equal to y times x squared plus 1. So then y is 4 over x squared plus 1. All right, so now the third one, final one here, g of 3. So g of 3 is equal to negative 3 to 3 of f of t dt, which is 1/2 times 5 times 4, plus a 1/2 1 times negative 2, which gives me 9. Where it's increasing in concave up, so g prime has to be bigger than 0, g double prime has to be less than 0, g prime of x is equal to f, so f has to be bigger than 0, that is on the interval from negative 5 to 2. G double prime has to be equal to f prime, which has to be less than 0, which is where the tangent line slopes are negative, so negative 5 to negative 3, union 0 to 5. So where do they cross over? Here's negative 5, here's 5. So I have negative 5 to 2 is where it's increasing. Negative 5 to negative 3 is where it's concave down, and then 0 to 5. So my overlapping region is from negative 5 to negative 3, union 0 to 2. And that's where it meets both conditions. And then the next one, so h prime of x is equal to quotient rule. So 5x g prime of x minus g of x times 5 all over 5x, the quantity squared. So I plug in my 3, h prime of 3. So 5 times 3, g prime of 3 minus g of 3 times 5 all over 5 times 3, the quantity squared. So I get 15 times negative 2 minus 9 times 5 over 15 squared, which is negative 75 over 225, which is negative 1/3. Part D, find the derivative. So p prime of x is equal to f prime of x squared minus x times the derivative of 2x minus 1. So p prime of negative 1 is going to be the same thing as f prime of negative 1 squared minus a negative 1 times 2 times negative 1 minus 1. So f prime of 2, and then I'm going to multiply this by 3. So f prime of 2 is, when I look at this graph, I'm looking at the slope here, and the slope of that graph using the mean value theorem is going to be negative 2. And then, I'm sorry, this should have been negative 3 times a negative 3, so I should get a positive 6. This value of 2 comes from the slope of the line where x is equal to 2 on the graph. And we use the mean value theorem. Okay, and that is it for this lesson.